Hey guys, we're going to work through two worksheets today through this video. The first one is a printed copy of a notebook paper. So it says solve, write in factored form. I've written the questions out here on my paper, but I did not take a picture of that one. So we're going to number this one 27. So I've already numbered it up here. So it's notebook number 27. I'm going to start out by using Desmos because they don't give me a 0 here. I know that my degree is a degree of 3, so I know that I should have 3 zeros. So the fact that that is a 3 means I have a degree of 3, and it means I have 3 total zeros. So real or imaginary, I have 3 zeros. All right, so using Desmos, I can type in my equation. So I have x cubed minus 2x squared plus 9x minus 18. If you look at the graph, it only crosses through one time. Well, I know there are 3 zeros, not 1 0, even though I can tell what this one is. So this one right here is at 2. So I know one of my solutions, because it says solve, is a 2. And this is where us learning long division is going to come into play. So I know that my 0 is 2. So one of my zeros. If I were there, I'd ask you, how do you write this in factored form? And hopefully somebody would be able to tell me that it's x minus 2. So this is how you'd write it as a factor. Now, knowing that my 0 written as a factor is x minus 2, I can divide in order to get this equation down to a quadratic. This is the whole entire point of us learning long division, was to be able to do problems like this one. So doing long division, I'm going to put x minus 2 in the front. And I'm going to put my polynomial inside of my division symbol. So now I'm going to try to figure out x times something is going to give me x cubed when I'm long dividing. So that value is x squared. So x times x squared is x cubed. So I'll write x cubed here. The mistake most of you are making is you forget to multiply by this negative 2 also. So the negative 2 times x squared is negative 2x squared. And then don't forget to change your signs because you have to subtract. And then when we subtract, this goes away. First term goes away. And in this one, the second one actually goes away also. So I don't have any x squareds. A negative 2 plus a 2 is 0. And then I can pull down my 9x and pull down negative 18. So now I'm back at like the first step. So I'm doing x times what value, still I'm talking about the same x. X times what value gives me 9x. So that is 9. So x times 9 is 9x. And then the negative 2, once again, you have to multiply that by the 9. So negative 2 times 9 is negative 18. And this, once you change your signs, is a 0. So I know that's going to be a 0 because I know that this is a 0, x equals 2 is a 0 of my equation, so I should get a remainder of 0. It is a factor. So I have one factor, and then I now have a second factor. This information on top here is my solution. So my two factors are x plus 2 and x squared plus 9. So I'm going to write it next to my x minus 2. This is factored form. So this is the first answer that I needed, or the second answer really. It says solve, write in factored form. So I've factored it. Now I need to solve it. So we know one answer, and at this point you should know how to get the answer. So right here we used the x minus 2 equals 0, and when you solve it, you get the 2. So we know a solution is 2, which we already knew from the beginning. And then the one that we haven't discussed as much is x squared plus 9 equals 0. So this is a little different. Y'all have done questions like this year, but we haven't done ones with an addition symbol in between them. So when you solve this one, I'm going to subtract the 9 because I need to get x squared by itself. And so this crosses off, and I have x squared equals negative 9. Now, if you think about it, anything squared can't give you a negative number. So like negative 3 times negative 3 is a positive 9. Positive 3 times positive 3 is a positive 9. Like there's no way to get a negative number from squaring it. So it's a little bit confusing. And this is where imaginary numbers come in. So it's like we have this imaginary number that would give us negative 9. Whenever we solve these problems, we have to take the square root. Don't forget the plus and minus to get rid of the squared. Y'all did this when we solved quadratics. So that made these cross off. So x equals plus or minus the square root of negative 9. Well, the square root of a negative number is not possible. It's not a such thing, except in imaginary numbers. So right here, we're going to change this. The square root of 9 is 3. So I know the square root of 9 is 3. And so if I kind of imagine that I took out the 3, you still have the square root of like a negative 1, because the negative just stayed. Like I still have this negative 1, this funky thing. Well, the square root of negative 1 is I. So here my answers are x equals plus or minus 3i. So because my degree was 3, I should have 3 solutions. Well, here I have x equals 2, and then I actually have 2 solutions right here. I have the solution x equals negative 3i and x equals positive 3i. So if I asked you to write the solutions, you could either circle these like this, or you could write this one out and write x equals 3i and x equals negative 3i. So if I wanted to write out my solutions, these could be the 3. Just depends on how you want to write them. I know that plus or minus 3i is acceptable. If you don't understand what it means, you might need to write out the 2. So the 2 solutions to this question was factored form up here. That's in factored form. And then my 3 solutions, x equals 3i, x equals negative 3i, and x equals 2. And don't forget, we started off by using Desmos to find one of the zeros. So that's number 1 on solve right in factored form. The second question, and if at any point you need to pause this, feel free. I'm also going to start this one off by using Desmos. So I'm going to type this one in because I still don't have, I haven't been given a 0, so I have to find it. These are the same steps that you would do. All right, so I can see I have 4 and negative 3. So over here, I'd write 4. So I have 2 of my solutions right here. The fact that I can see these 2 on my graph and the only 2 that I can see, I know that I have 2 real solutions. And in total, I should have 4 solutions because I have an exponent of a 4. So if the question that I'm asking you is solely how many real solutions are there, you would be able to tell me that there are 2 real solutions and there are 2 imaginary solutions, because to get to 4, I'd have to have 2 imaginary. So we're going to solve this one. Whoops. I know that I have 4 and -3 as zeros, so I can divide by their factors. So I know the factor for 4 is x minus 4. Remember your sign change. And the factor for the 3 is x plus 3. So I start, and this is what's a little tricky, I start with my original equation. So I'm starting with x to the 4th minus x cubed minus 7x squared minus 5x minus 60. And I'm going to divide by x minus 4. It doesn't matter if you use x minus 4 or x plus 3. In the end, you'll end up with the same answer. So I have x times something is x to the 4th. So x cubed. I'm like 1x lower. So I get x to the 4th. Then I do -4 times x cubed. So don't forget to multiply by that -4. -4x cubed. Sign change. That goes away. And I have 3x cubed. And I bring down -7x squared. So x times something gives me 3x cubed. I know it's going to be a 3 because I have like a 1 times 3 gives me 3. And then I have the -4 times the 3 for my second step, but I still have to get the x's. So I have x times x squared gives me x cubed. So I do x times 3x squared is 3x cubed. And then -4 times 3x squared is -12x squared. Sign change again. These go away. Should always cancel out. And I have 5x squared. And it's positive because I have -7 plus 12. And then I bring down the -5x or minus 5x. So x times something is 5x squared. So it's x times 5x will give me 5x squared. I'm running out of room down here. And then -4 times 5x is -20x. So then here, I have to change my signs. These go away, and I have positive 15x, and I bring down the -60x, -60, no x. So then I have x times something is 15x, so that is going to be 15. So x times 15 is 15x, and then -4 times 15 is -60. I change my signs, and then these go away, and so do these. Yay! I have a 0. So I know that I did my division correctly. All right, so that's just the first division in this one because you have 2 zeros. So that's just the first part. You also have to divide by x plus 3, but you don't divide the original. You actually divide this answer, you divide your solution by x plus 3, because each time that you divide, you're taking out one of the factors until you end up with x squared, and we know how to solve something that is squared. So we're also going to do the division of that by x plus 3. Oh my goodness. So here I go. I have x plus 3, and I'm going to divide x cubed plus 3x squared plus 5x plus 15 by this value. So this is just this numerator up here at the top. I mean, not numerator, my quotient, my answer. So x times x squared will give me x cubed. And then don't forget to do the 3. So 3 times x squared gives me 3x squared. You change your signs, and you end up with nothing, like they both cross off. And you bring down 5x. They won't always both cross off, but sometimes. So now I have x times something gives me 5x. So 5. X times 5 is 5x. 3 times 5 is 15. When I change my signs here, these both also cross off. So I have my 0. That means I know what my two factors are, x minus 4 and x plus 3. The answer to this one is now my new factor. Your factor won't always be at x squared, but in the last problem and this problem they are. That's only because there's not a center term. You know, when we do like a, b, c with the quadratic formula, there's no b here. When there's no b, you just write it as a factor. So if there was a b value, we'd have to actually factor the problem if it's factorable, or we would just have to solve using the quadratic formula to get our solutions. So here I have 3 factors, x minus 4, x plus 3, and then I'm just going to add right here x squared plus 5. This is my new factor. So this is part of my solution. Let's say turquoise is my answer for it. This is part of my solution. And then the last thing I have to do is get all of the actual answers. So right now I know x plus 4 and x minus 3 are 2 real solutions, but I'm still missing 2 solutions because I should have 4 in total. So you have to actually solve x squared plus 5. This is just like what we did a second ago. You set the factor equal to 0, and we're going to actually solve it. So I subtract 5 from both sides, and this goes away. So I have x squared equals negative 5. Now you have to get rid of the squared, so you take the square root and you put a plus or minus whenever you do that. So these cancel out. So I have x equals plus or minus the square root of negative 5. Well, we don't like square roots of negative numbers, so we change that and make it plus or minus the square root of 5i. Don't take the square root of 5, like just leave it as the square root of 5i, because the square root of 5 is not a nice number, so we don't actually take the square root. So we're going to actually leave this answer either written as 1 plus or minus the square root of 5i, or you can separate it into the square root of 5i, I is on the outside, and this negative square root of 5i. So we have all of our answers, 1, 2, and then 3, 4 at the top. So those are all of my solutions. So the answers to number 2 are 4, negative 3, square root of 5i, negative square root of 5i, and then the factored form, x minus 4 times x plus 3 times x squared plus 5. So those are your first 2 questions. Watch the next video for the next 2.